Okay, now we're in section 11.3. This time we're comparing population means independent samples. So this is referring to samples that are completely independent of each other. They are not matched pairs data. So we'll see how this compares and how it's a little bit different from the previous section. A researcher with the Department of Education followed a cohort of students who graduated from high school in 1992, monitoring the progress the students made toward completing a bachelor's degree. One aspect of his research was to determine whether students who first attended a community college took longer to attain a bachelor's degree than those who immediately attended and remained at a four-year institution. The data in the table summarize the results of his study. Okay, so notice how we have, first of all, two different sample sizes, two different sample means, and two separate sample standard deviations. So we will need all 6 of these values to put into our calculator. So the question is, does the evidence suggest that a community college transfer student takes longer to attain a bachelor's degree using alpha equals 0.01 level of significance? So now we're comparing two different population means. So we will see mu1 and mu2 in our hypotheses. So H now will always be the same, that the population means are equal. So for H1, it's saying, does it take a longer amount of time for community college students to graduate? So in the table, we are seeing that the sample mean for community college students is higher than the sample mean for students who go directly to a four-year institution, which means that this evidence does support this hypothesis that it takes longer for community college or transfer students to get their degree. Okay, so I want to get the p-value. So I'm going to go into my stat tests menu. And this time I'm going to go to 2sample t-test, which is number 4, 2samp t-test. And then we press enter. And you have a choice of input, data, or stats. In this particular example, we were given statistics. We were given X bar and S for 2 different samples. So I'll change the input value to stats. And then X bar 1 is in the table as 5.43. That was the sample mean for transfer students. S1 is 1.162. That is the sample standard deviation for the transfer students. And the sample size was 268. So notice that they're in a different order in the table than in the calculator. So just be sure that you're paying attention to what you're typing in. It might not necessarily be given to you in the order that the calculator is asking for it. All right, X bar 2 is the graduation time for the four-year students. So 4.43 was the sample mean. The standard deviation is 1.015. And the sample size this time was 1,145. Our alternative hypothesis was a greater than hypothesis. For pooled, we're going to leave that as no every single time. Don't worry about it. We'll never have to change it. It just means that we're not assuming equal variances for the two populations. And then go to calculate. Okay, here we've been given a p-value of 2.84 e negative 32. So that is an extremely low p-value. And if we're going to round it to 3 decimal places, it's going to be rounded to 0. Because what we're essentially looking at is a 0 point and then 31 zeros and then a 3. So that is extremely small. So it rounds to 0. So do we reject H0? We certainly do, because that is, well, obviously 0 is less than a 0.01 level of significance. Okay, so state the conclusion. Well, there is sufficient evidence to conclude and then let's see what the alternative was. It takes longer to obtain a bachelor's degree for transfer students than those who immediately attend a four-year institution. So there is sufficient evidence to conclude that it takes longer, for transfer students to attain a bachelor's degree than for students who do not transfer. Remember that your wording can be different from mine as long as it says whether or not there's sufficient evidence, and then you somehow restate the alternative hypothesis. All right, let's try one more, a little bit different. On this one, we're given data, so that will change our input value. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds of males differed from that of females to a go, no-go stimulus. So the word differed is important. This gives us a hint for our alternative hypothesis. The researchers randomly selected 20 females and 15 males to participate in the study. The go, no-go stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. The results are as follows. So we have some times in a table. Test whether there's a difference in the reaction times of males and females at the alpha equals 0.05 level of significance. State the conclusion. So first, let's start by writing our hypotheses. H0 will always be the same, that there is no difference in the reaction times. So that mu1 is equal to mu2. And then H1, the hint is the word differed and difference, that the reaction times are somehow different, not giving whether or not we think one is slower or faster, just that the reaction times are different. So in order to do this hypothesis test, we need to go to our list. So stat, edit, and type in the values. I already did that so that you don't have to watch me type them. So I put the female values in list 1 and the male times in list 2. So you may want to pause the video and type those in on your calculator. Once you've finished typing them in, we can go ahead and do our test. So we go to stat, arrow across to tests, and once again we're looking at number 4, a 2-sample t-test. This time I'll change the input value to data, and I did use list 1 and list 2, although you can use any list that you want. Our alternative hypothesis was a not equal to hypothesis. Pooled, leave it as no, and then go to calculate. Okay, so we got a p-value that was pretty high. It's about 0.540, so let's write that down. P is approximately equal to 0.540. That is definitely greater than alpha, which means that our results are not significant. We do not have strong evidence to support the alternative hypothesis, so we do not reject H0. Okay, so we can go ahead and now write out our conclusion. There is not sufficient evidence to conclude that males and females have different reaction times to a go, no-go stimulus. One thing I want to point out about this problem is that we are testing population means, but the word mean doesn't appear in the problem. This is going to happen quite often for tests for means. If they just have you compare amounts, you pretty much have to conclude that they want us to compare the means. It doesn't really make any sense to compare anything else in this case. There definitely aren't any proportions involved. So even though the word mean doesn't really show up, what they want us to do is just assume that we're comparing means for a problem such as this one.